is for vertical bar. Okay? More than that is 5, but minimum 4. Okay? Now, all this vertical bar come down. Notice if the bar just goes straight up, it's very slender. Is that right? So you're going to have to hold it together. And you need tie to hold it together. Okay? So if you draw a cross section, if this is the cross section of your column, this is your vertical bar. The tie looks just like stirrup. Okay? If your column is big, let's say 3 by 3 feet, okay? You might have many bars. In that case, one tie is not good enough to hold all of them. So you might have multiple ties. You might have one more in the middle. Okay? Guys, 333, I did not push you guys to look at the code. Okay? Now is the time to go to the library, pick up the ACI building code, and they will show you some of this in the back. Okay, clear? Okay. When our column is big up to a certain level, single tie won't work. Okay? Now, so the column has, besides the concrete portion, there are at least 4 vertical main bar to carry the load, right? You have all this tie. So you pick a size for the tie. Okay? Number 3, number 4, number 5. Notice why I start from the smallest, because the bigger the bar, the harder to bend. See what I mean? Okay? So if you say number 9, how many is number 9?
1 and 8.
Over 2 inches, 2 and 8.
Yeah, you try to bend it. Only he can do it.
Maybe Wayne.
Wayne? Good luck, guy. We used to have a machine in the lab. It's like just a crazy lever arm, so you can bend the steel. But I think my beloved Alan decided to throw it away. Anyway, okay. So the requirement for the tie, you pick this, right? The requirement is the spacing. Spacing, okay? The spacing of the tie controlled by 16 times diameter of the main bar, main vertical bar. 48 times the diameter of the tie. And the least dimension of your column. And the smallest of these 3 will be the spacing that you use. Okay, okay? That's typical design. Okay? Typical design. If you design column in California, earthquake, retrofitting, the spacing, the tighter the spacing, the more confinement you have for your column. It's harder to break due to earthquake. Okay? So in the process of retrofit any existing column, old column, they will put some kind of additional tie, very tight around it. Okay? Steel tie may be hard, so they may wrap it up with carbon fiber. Yes, and
When you say short column, are you
Yeah.
saying we don't have to worry about column buckling?
yeah. Okay.
So
Now
when
it's
you do
controlled by KL over R.
Right.
If KL over R is less than 22, then you don't have to worry about buckling.
So all these
If it's
columns.
more than, yeah, in regular building, it's, most of the time it's less than that. Okay, now, let's come back. So, vertical bar, the tie, okay? Now, how to come up with vertical bar? This is the load you want. Okay? This is the column. Okay. Let's say this is our floor plan. There are 4 columns. (20 feet by 30 feet). Okay? Live load 40 pounds per square foot. Okay? Column C1, 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 C1. Why I call everyone the same? Symmetrical, right? Shop is split between column. Split between column. Anything on this corner supported by that column. Okay? Now, when you draw the structural floor plan, you connect all your columns with a beam. There will be beam here, beam there, beam here, beam there. B1, B1, B2. Oops. Not good. That's not the way to draw it. Okay? B2, B2. So if I have just one slab, 4 column, 4 beam, that's my label, okay? And this is my slab S1, okay? The slab is a two-way slab, all right, in this case. Now, we want to decide the load, right? So if this is 4 inches slab, and this is, let's say, 12 by 24 beam. 12 by 24 beam. 12 by 24 beam. Notice column C1 carry 10 feet of 12 by 24, 15 feet of this B1, and 4 inches of slab, right? Plus the live load on this. Sorry. See it? You add all of them up, you get there. Don't forget to multiply 1.2, 1.6. So when you have this, P concrete, P steel, okay? Total load equal to wood carried by steel and wood carried by concrete, okay? Stress times area. Stress 0.85 FC prime times area of concrete with steel. Area of steel. Add them up. Okay? Reduction factor, V. You have another factor for column that the code gives you, okay, 0.7, 0.75, 0.8, go check it, okay, and that's equal to your PU, okay? Now, you know this ultimate load from P dead load, P live load, right? 1.2, 1.6, Fy, Fc prime, you have it. You have 2 variables, notice that? Area of concrete, area of steel. But if you said that, hey, I reinforce my column, what is the maximum reinforcement, the rate of reinforcement in beam? Row in beam.
2.5.
0.5 to 2.5, okay? Row mean is about 0.0033. Row max is about 2.5 something, 2.6. But the practical range for beam that we usually reinforce is between 0.5% to 2%. Okay? For column, what is the reinforcement range? Muhammad,
Yeah.
reinforcement for column. Practical range for row.
I'm gonna guess 1 to 8%. That's what
You
it
don't
is.
have to guess.
Is it right there?
That's what we usually use. So that row, okay, reinforcement ratio is AS over AC, or gross area. Okay? So if I say that I reinforce with 3%, divide this by gross area. This is approximately 1 cool AG out. Okay? This is your row. Okay? So if I put row 3%, 0.03, I can solve for the size of the column. Easy? So once you get the size of your concrete column, 3% you get your AS. Done. Easy, Andrew?
Yep.
So you get this from the floor plan. So don't make your life miserable, okay? Some of you said, okay, hey, all this load, can I put uniform load and analyze the beam, find the reaction? You can do that, okay? But it's pain in the neck. You split this up, okay? Everything go to that area and quick, dirty, hard clean. It worked, okay? And that's how we use it for years. Not hardly anyone split it into different beams, analyze the beam for support, those kind of detail. Yeah.
Is, in this case, is 0.8 feet or is it 0.8 times feet? I guess.
Oh, there are two of them. There's a fee, and on top of that, there's a 0.8
It is
or
both?
0.7
Okay.
something, two of them. Okay? And when you multiply all of them, it came out like 0.7, 0.7. All right? Review the column. You get these two constants. The reason I say that because this 0.8 or 0.775, it is rectangular column, it has one number. It is spiral column, it has another number. But it's 0.7, 0.75, that's it.
Okay.
All right? But I can dig it up if you guys can't find it. Okay?
Okay. Matthew, what's fee, 0.9?
Phi is the reduction factor. Remember for bending is 0.9,
Yeah.
okay? For shear is 0.92. It used to be 0.85.
Oh,
But for column, it has different number. You want to dig deeper. Go to the column section, and the first thing they will talk about is what's the fee. Okay? And fee for spiral column, circular column, and fee for rectangular column will be different. Rectangular column is weaker than circular or spiral column. All right? Anything else that you guys want to know? Sure, 2 weeks?
Do we?
Next week, what you guys